All right, in homework 4.7, you're finding the average value of a function. And before we get started on problems, let's make sure we all understand that there are two different average values we found. The average rate of change of a function. So if there's a function, the average rate of change between A and B is, on average, how much was it going up by? And that's the slope. Average rate of change is f of b minus f of a over b minus a, y2 minus y1 over x2 minus x1, and it just says, hey, on average, how much was this going up by each time? The new one we have is the average value of a function. And so again, if we have a function and we want to know what the average value of the function is, we're talking about the average y value was. How high on average is this function? And so the way we do it is we find the area of this guy and then split the area up evenly. And so what it looks like is we take this area and end up with an area that's of equal height. We make it into like a rectangle that's all the same height. And so the way we do that is the average value of a function is, this is f, it's the integral from a to b, this is a and this is b, the integral from a to b of f, because that gets you the area. And then what we do is, that's the total area, we divide by the length of this rectangle, b minus a, to get what the height of the rectangle would be. And that tells you what the function was on average, how high it was on average. There is a relationship between these two, right? Remember, if you think of the original function as a derivative, and you want to find the average value of the derivative, then what you're doing is you're doing the integral from a to b of f prime divided by b minus a. That's the average value of this function. And what this integral is, by the first fundamental theorem of calculus, is this is f of b minus f of a over b minus a. It's the average rate of change of the antiderivative of this guy is the same as the average value of the derivative. And that should make sense, right? The average value of the derivative is the average rate of change of the original function. So let's see how we can apply this. You're supposed to find the average value. I'll do b, I guess. So b says to find the average value of this guy from 1 to 3. So it's the integral from 1 to 3 of 4x squared plus 4 over x squared. This is the integral of 4x squared plus 4 times x to the negative 2. And we can distribute here. So we get just 4 plus 4 over x squared. 4x to the negative 2 is 4 over x squared. And this is what we're doing the integral of. And I've left a key component out. I'll put it in at the end. I just wanted to save some space here. This integral is, we do the antiderivative. So this is, I guess I should have left it as 4x to the negative 2 here. Sorry. Made some extra work for myself. So this power will go up by 1, divide by negative 1, and we'll do this integral from 1 to 3. So we plug in 3, we get 12 minus 4/3 minus, this is with 3 plugged in, minus 4 minus 4. So this is just 12 minus 4/3 because 4 minus 4 is 0. Now this is the integral. So it's, what is this? 32/3. That's the integral from 1 to 3. But what we wanted was the average value. The average value is this integral all divided by 3 minus 1. So it's this integral divided by 3 minus 1, which is the same as 32/3 times 1/2. Dividing by 2 is the same as multiplying by 1/2. And so we get 16/3. That's the average value of the function. Okay. Let's see. I'm going to do C here. It says find the total distance traveled by the particle from time equals 0 to time equals 3. To find the total distance, we needed to do the integral of velocity from 0 to 3, but this total distance part is a key word. We're actually doing the integral of the absolute value of velocity from 0 to 3, because we don't actually care whether the velocity was positive or negative. We're going to add it all up. And so what we have to be careful of here is, what if the velocity is negative at some point, right? What we need to do is we need to count that as positive velocity. And so the first thing to do is to find where the velocity is 0, if the velocity ever equals 0. So what we do is we see where is v of t equal to 0. 3t squared minus 2t minus 1. We're seeing, does the velocity ever change directions? Because if it does, we'll need to split it up into two separate integrals and make them both positive. So this needs to equal 0. This can factor. This is 3t times t, and it's minus 1 plus 1. So t equals 1 and t equals negative 1/3. So there is a time between t equals 0 and t equals 3 at t equals 1 where the velocity changes directions. And so what we're going to do is we're going to do the integral from 0. Notice that this time the velocity also changes directions, but it's not between here and here. So since we're trying to do the integral from 0 to 3 of the absolute value of velocity of t, what we're going to do is we're going to just split this up into two separate integrals. One where it's all going to be positive, and the other where it's all going to be negative. I actually don't know which one's going to be negative and which one's going to be positive yet. So what I'm going to do is I'm just going to do both of these integrals and then take the absolute value of them at the end and then just add up the integrals. So the integral from 0 to 1 of the velocity function is, so we're doing the integral of this velocity function. So we're going to get t cubed minus t squared minus t from 0 to 1. We're going to do the absolute value of that guy, minus t cubed minus t squared minus t, evaluated from 1 to 3. And this looks kind of silly, right? We're like doing these two separate integrals. The reason we're doing it, again, I don't know why I did minus there. We're going to add these up. The reason we're doing this is that one of these is going to be positive and one's going to be negative, and so we're going to end up doing the absolute value of it to make them both positive, because we want the total distance. We don't care whether it moved backwards or forwards. So this is 1 minus 1 minus 1. This is negative 1 minus 0. So that's with 1 plugged in, minus with 0 plugged in. This one is 27 minus 9 minus 3 minus 1 minus 1 minus 1. So we've got here, we've got the absolute value. This area was negative 1. Negative 1 minus 0 is negative 1. So the actual graph must have been something like this, right? Where the velocity was negative at first. This is v of t. Until t equals 1, and then it became positive. So we've got negative 1 plus, this is 18, 15, minus negative 1 is 16. And so we end up with 1 plus 16. Basically, the particle moved 1 to the left and 16 to the right. The total distance is 17. All right. I like number. No, I've already done 2 here. Let's do one more. Let's do B. B is different. It says use a left Riemann sum to estimate the average value. So the average value is the integral from a to b of f of x over b minus a. And we're not actually calculating the integral from a to b. We're using a left Riemann sum to estimate the average value from a to b. And so that estimate, the average value from a to b of f of x, is going to be equal to this Riemann sum. So here's x cubed plus 2. We're doing a left Riemann sum. It says with 2 subintervals, we're going to make 2 little things between 0 and 2. This is the area we're doing. And when x is 0, the y value, we just plug it in. The x value is 2, 0 cubed plus 2. That's our first rectangle. And when x is 1, this rectangle has a height of 3. And so the Riemann sum for this integral that estimates this integral is this rectangle has a height of 2 and a base of 1. This rectangle has a height of 3 and a base of 1. And so this integral is equal to 5. It's not a very good estimate. I mean, we can tell that there's this huge underestimate, and it should be quite a bit less. So, but we got that the average was, we got that the total area was 5 from this Riemann sum. And so we need to divide that by 2 minus 0, because the average value is the integral, which we estimated to be 5, divided by b minus a. So 5 halves is the average value. Okay, which, man, sure looks like the answer key says 1.5, which is not right, I don't think.